Hello everyone and welcome to Module 7 on Object-Oriented Programming with Python. I've constructed most of this content from scratch, so I hope you find it useful, and it is meant as a segue into our graphical Python programming class, CSC-121, that's intended to be the second Python class that students take. So object-oriented programming will be the future, and it is the future of programming, but you will be introduced to a lot of new terms, and some things have more than one name that means the same thing. So I will try to point that out and use, two or three names when we talk about things, just so if someone comes to you later or you pick up a document and on object-oriented programming and read it later, that you have some kind of an idea of what they're talking about. So I'm going to switch over to share my desktop where folks can see Blackboard. So you should be able to see the Blackboard material now. I'm going to check it out just to make sure, and looks like you are. So this is Module 7 in Blackboard for our CSC-120 class. So you'll notice the Module 7 objectives there. Don't get caught up with the dates and the menus on the left-hand side in Blackboard. I'm actually in the development class. It's a shell that I use to create classes, and then we copy them into the various sections that students take. So you won't see some due dates and things here that will be there in your class when you're actually looking at this material. So I wanted to give you that little heads up. So you should be able to see the Module 7 objectives here, and the first one is implementing abstraction. Now, abstraction is hiding the details so that you can kind of get the big picture. You may hear some folks talk about the 10,000 foot view of things, where, if you're really up high, you can see a lot of things at once. So abstraction helps us to understand what a program is doing, and it lets us make something that someone could come behind us and maintain. So it makes it easy on the development end. It also makes it easy on the maintenance end. So you're going to learn some new words here. You'll notice the next bullet point says define a class, constructor, and destructor. So first off, we need to talk about what a class is. So if you'll notice the little graphic over here where I'm mousing, you'll notice there's a blue circle and it says class. Then it has some dotted lines and it goes over to these pink circles, and there are multiple pink circles that say objects. So these are two words that you need to understand, and you need to understand the difference between them. So first off, a class. A class is like our blueprint. It is the pattern that we use, the recipe, if you want to think about it that way. So you heard me say three different things to define a class. A class could be a recipe, a blueprint, and a pattern. Okay? So if you think about a set of blueprints for a house, if we've got a blueprint for a ranch style house, and you go to a housing development, you'll see a lot of those houses that look almost the same. That's because they use the same blueprints or plans to build those houses. Just because we've got this blueprint doesn't mean we're just going to use it once. We could use it over and over and over. And all those houses in the housing development might be different colors. So while the basic structure of the house is the same, they might be painted different colors. They might, I don't know, one might have carpeting and the other might have hardwood floors. So a class is the pattern or the blueprint that we use to make objects. And you notice I said objects in the plural sense, because we can take that blueprint and make more than one house or whatever object that we're intending to make. Just like you know, they say identical twins share the same DNA. So identical twins. So if you had that DNA, the DNA is the pattern for what color hair that person has, what color eyes, and so on. And so think of that class as the DNA, the class. And you may hear this when we're talking about a class. I try in the material to call them class definitions in an effort to reinforce to you that a class definition is, you know, where we're defining what that class or what that is going to look like. When we actually make an object in our program, then we end up instantiating an object from that class. So if you think about this, I know everybody's had functions already in Python because that was one of the earlier modules. You may remember we could def out a function in Python, but if you never actually called that function, that code never really got used. It just got stuck into memory and it never actually caused anything to happen. Okay? Well, think of that function definition as the same thing as a class. We could create a class definition, and that pattern is sitting out there in our program, but if we never actually instantiate, and that's a new word, instantiate means to bring into existence. If we never instantiated that class, then we never actually had an object in our program that could do anything. All we had was a pattern if we just had a class definition. Okay? So I got into the next bullet here that says instantiate object variables. So usually when we create these objects, we actually create an object variable, and that variable is a points to that object, so it's called an object variable. Okay, so each of these classes, you'll notice here in my graphic, it's got at the top, it's got this little green bubble, and it says integer age, string name, string greeting. Okay, those are all variables or properties. Now, in a class definition, we really start calling them properties instead of variables. Okay. Down here in the bottom, in the purple, it's got print, input, output. Those are methods. A method actually causes something to happen. Okay? Some action to take place. So, again, variables are properties of our class, and methods down here in the bottom are things that cause some action to happen. And you'll notice here it's got access attributes of object instances using the dot operator. And then lastly, we'll talk about how to define private class attributes and understand the limitations of object encapsulation. Okay? And encapsulation has to do with data hiding. These things that are inside of our objects when they're created, okay, when we instantiate an object, things outside of the object can't get to those attributes or methods if they're private. Okay, so we'll learn how to make those things private down towards the end of this material. So here's a module assignment summary. I know it looks like a lot, but it's actually not. I tried to break this material up into little one-pagers. So each of these links, with the exception of this link to the W3 Schools website, is actually 1 page or so of material. So I'm going to click on the introduction here and you can see what I mean. So here's that 1 page. It's a intro to object-oriented programming, and you'll notice it opened a new window for us, so I could still go back and get to that stuff. So here we are. Okay, so you see what it says. Object-oriented programming enables a programmer to develop large-scale, that means big, programs and GUIs. And GUIs are a really good use case for object-oriented programming. They abbreviate that as OOP a lot. Okay, so a lot of the features that we had previously in Python didn't give us enough abstraction, okay, hiding of the details to make our programs easy to understand. So with object-oriented programming, we can develop a class definition. Remember that blueprint that I was talking about? We can develop a class definition, put it in a Python file, and then import it. So you remember back in the first week of class where we were talking and using turtle graphics? Well, guess what? Turtle graphics, the turtle was actually an object. The turtle was actually, when we brought turtles into our program and gave them a name, like Ken is my first name, I had you create a turtle object with your first name, okay? You didn't see all the stuff that went on behind the scenes to make that turtle move forward or turn left or turn right or set its shape. You didn't see all that stuff because it was in a class definition, that we imported. All that stuff was hidden, wasn't it? It was abstracted from you, so all you had to know is, I'm going to have this turtle in my program, and I know that I can make that turtle move forward, I can make that turtle move right, I can make it move backwards, and all that other stuff, okay? We could say pin up, pin down, all that stuff with the turtle, okay? But you didn't know all the Python code that was going on behind the scenes. That's what we mean when we say abstraction. It made the program easier for you to comprehend and understand what was happening. So there's a lot of that stuff that goes on that's pretty darn complex to make a GUI, a graphical user interface program. Okay? And so in order to hide all that complexity and to make our GUI programs run reliably and easy to maintain, we use object-oriented programming to develop GUI applications. Now here, this is actually a GUI that I designed in Qt Designer, okay? And this is a GUI from the CSC-121 class at RCCC. Now this whole box right here, where I'm mousing, this whole box was actually what's called a dialog, and it was a dialog object. So the whole little window here that's dark gray and light gray, that was a dialog object. These OK and cancel, those are push button objects. This is a label object where it says enter your name. This is a line edit. A line edit is what it's called in Qt. A place that lets you key something in and use it. These square things were check boxes. These round things were radio buttons. So you could see our whole GUI here where I'm mousing was a bunch of objects that we brought into existence. We brought those objects into existence from the PyQt5 library that had a bunch of class definitions in it. It had the class definition for what a push button would be, okay? And when I drag this to my dialog in the designer, I give that push button a name. We instantiated a push button object, and you give it a name. I usually call them like push button OK. So this might be push button cancel. And so these are two instances of a push button class, okay, a push button class definition, but they have different things about them. They have different properties. What the text that's shown inside of the push button, that is a text property that we set. So two different objects in existence here, each with different properties, but they're still using the class definition for a push button. Remember, the class definition is the pattern that we use to create an object. Okay, so W3 Schools has some excellent material that you can use to get started with object-oriented programming. I'll pop into that here in just a moment. Some other benefits that you can see here of object-oriented programming, they go really far beyond abstraction. You'll notice creation of reusable components. Okay, reusable components. Well, with this GUI right here, we didn't have to write the code to create a push button over and over and over. We had that object out there. We could just use it to instantiate. We had that class definition. We could use it to instantiate these push button objects, okay, making something reusable. They actually have inheritance where you can have a class definition that inherits another class definition so that you don't have to reinvent the wheel, so to speak. We don't get into inheritance in the CSC-120 class. We get into that in CSC-121 because every one of our dialogues actually inherits a class definition from this PyQt5, but we don't get into inheritance in this class, but it's mentioned right there. And as you can see here, greatly increased reliability of our programs because we're not in there monkeying with the code that says what a push button looks like and what it all the things that it can do. We just bring a push button object into existence and we use it. So we're not in there messing with the code that tells Python how to make one of these things. So that makes our program much more reliable. The variables or properties that are inside these class definitions can't be accessed from outside unless they're public. And we'll talk about the difference between public and private properties right now. Let's get into it. Let's go to W3 Schools. So here's W3 Schools Python classes and objects material. And here is the code to create a class definition. This is a class definition. Remember, I said a class definition is a pattern that we use to create an object. So what this says is we're going to make a class definition. The name of it is going to be my class. It's going to have one public property named X. Okay? So right now, if we put this code in Python, it's actually not doing anything, just like if we had a function with the def and we made a function and never called it. If we never actually bring an object into existence using this pattern, my class, then we don't have one. So if I click on try for yourself, you can see that they brought it in and then they did a print here and it just showed you that that's all that's out there right now is just a class definition named my class, and that's all. So really not much to show with that particular example. Now here's where we start making it do some work. Okay, so if you have this code here at the top of your Tawny program, and then you put this code in, let's talk about what's happened. Here's the pattern to create a class, okay? Class definition, name my class. Now here's where this line where it says P1 equals my class, this brings that object named P1 into existence. This is called instantiating an instance of my class, and it's going to be named P1. Now, remember I told you that unless we do something special, every variable that we create inside of a class is public unless we do something special. So we didn't do anything special. So down here, we can actually get to that. You see what they're doing? They're printing p1.x. So x is going to have a 5 in it. So right here's where they accessed that property. X is a property. It's public. So we can get to it. Here, when this print is done, we are outside of that class. So we're outside of this class definition. So if we want to get to something, it has to be public. So I'm going to click on try it for yourself, and you can see there's where it printed the 5. Okay? Now I'm going to steal this code and show you just briefly that if I made this X private, we wouldn't be able to get to it. We wouldn't be able to get to it. Okay? So, I'm going to start Tawny up here. Okay. Pasted that code in. Let me go ahead and get my indentation fixed here. Got to be careful with the indentation in Python. And I'm going to go ahead and file and save as. And I'm going to save this in a folder that I've created called Module 7. And I'll say W3 Schools 1.py. How's that? Okay, so I've got that code in Tawny. You can see when I run it, I get a 5 out down below. Now, if I had done this, okay, notice what did I do just then? I put two underscore characters in front of the name of that property. When I do that, that makes it private, okay? You see what I'm getting now? Let's try accessing it. Let's try accessing it with the underscores here. You see I'm getting a traceback error. You see that? So that's the way you make a property or a method private in Python. You put these two underscore characters in front of it. Okay, you can see I can't get to this now, can I? If I take those underscores off, okay, like we're in W3 Schools, all of a sudden it's public and I can get to it outside of that object or outside of that class. Okay? So just a segue in, we'll talk more about that towards the end of this module, and I'll probably break this video into 2 videos because we can talk about a lot of stuff here. So back to the W3 Schools. Here's where we start talking about the constructor. The constructor. The constructor gets run when we instantiate an object. When we instantiate an object. Okay? That means that our constructor actually gets run when this line happens. See what I highlighted? Now, we don't have a constructor in this class definition here. We don't have one. If we were to put one in here, then it would have run when this line happened. Okay? So, I can go ahead and put one in here just so you can see how that works. But there's a lot of moving parts here when we start doing this. So the constructor is what happens when we instantiate an object from a class definition. Okay? So let's put one in. Right here, this is a line I'll just copy and I'll save myself some typing. And I'm going to paste it into our little example here. Okay? And this needs to be indented. If I can get it indented, like so. Okay? And there we go. Now we have a constructor in our class. This is our constructor. Okay. This is our constructor. It gets run when this line happens. Notice, what does it have right there? Self. Self. This is the first parameter that's passed to every method that we write for our class is going to be an instance variable. it references P1 that just got created. Now, in order to do this right, I need to do this, self.x, okay? So now I've added a little bit of code to this, but when our object is created right here, P1 gets created, this code right here is going to run. It's going to create an X that then we can access down there. So I actually made this more of what you would see in the real world. That example from W3 Schools wasn't really real world. This is more real world, and you can see that I'm still getting the 5 out down below. If I clear that and run it again, you can see I get the 5 out. Okay, P1.x. So that constructor right here, I never called the constructor, but it got run. It got run when this line happened. And if you want to prove it to yourself, we can take this line out right here, or well, let's leave it in, and let's put ourselves another message in here. I'm going to say print hello from the constructor. Okay, so what you're going to see when I run this program the next time is instead of seeing 5, you're going to see hello from the constructor, and then you're going to see this line happen. Okay, so here we go. Hello from the constructor, and then the 5. Okay, so you can see that happened right there. Okay, so the constructor. Okay, right here, let's talk about what they were doing in W3 Schools a little bit. So I told you every method of our class definition has to get a reference to the object. So you can see self is there. You can see they've got 2 other parameters, name and age, that are getting passed. Here, they're just taking whatever came in for name, putting it in an instance variable named name, and here they're taking age, putting it in an instance variable named age. Okay? Now, where did these things come from? Right here, when they instantiated a person, when they brought an instance of a person into existence, this parameter, John, is what's in name. 36 is what's in age. Now, did you notice when we instantiated that object that we didn't pass self to it? Okay? You only have this when you're in your class definition here. When you're in the class definition is when you have self. When you're outside of the class, and we're outside down here, right? We're outdented all the way to the left. So we're outside of this class definition. When you're outside of it and you want to create an instance of a person, you don't pass self to it here. Okay? And then here they just ran it. So let's go back to our material here. So we've looked at the introduction. We've looked at W3 Schools a little bit. Okay? Let's look at the purpose of the class definition. Okay? And it says that a class definition, now remember, this right here is a class definition. This is what I've got highlighted in orange right now. Okay? Purpose of a class definition is it defines the properties and the methods. The methods are also known as behaviors, okay, that are brought into existence when an object of that class is instantiated. Okay? And it goes on to say a class is considered a blueprint. We already knew that. We've talked about that. Okay? So, object-oriented programming, we're using objects in our programs, okay? And an object represents an entity in the real world. Usually they are nouns. If you looked at a sentence, and picked out the nouns, those would all be good candidates to be objects when you were writing a program. For example, if we had a program that was printing, I don't know, student GPAs or something, we could have a bunch of objects, an object for each student. Every student would have the same properties like GPA and, I don't know, first name, last name, student ID. All those things are common to students. So we could have a bunch of different student objects in our program. Desk could be a candidate for an object. A circle, a button, even a loan could be considered an object. They actually have object databases now. Oracle has been coming out with some object-oriented databases. And if you think about it, that does kind of lend itself real well to an object-oriented programming model. Okay? When we bring an object into existence, Python assigns it a unique ID so that we can get to that object at runtime. Okay? We don't usually mess with this ID. It kind of happens behind the scenes. We create a variable to get to our object. When they talk about the state for an object, it's those things that are unique to that object. Okay? The state for this particular person object here, the state would be John and 36. We could have had more than one person object in our program. Okay? If I take this code and copy it and go back to Tawny here and let's paste it in. Okay? Let's fix our indents. Remember, when we have these indents, they have to be perfect in Python. Okay? So here I'm going to go ahead and put some extra code in here. P1's name. And P1's age is. Okay. And so let me run this. Okay, you can see P1's name is John. P1's age is 36. Well, I could actually have a bunch more people in my program. Let me just copy this and we'll change it. Okay, so here we go. So I'm going to make myself a P2 and a P3. So now we're going to have 3 people in our program. We're going to have John, Ken, and Bill. Actually, let's do Jane. Okay, so we've got 2 guys and a lady in our program now, and let's go ahead and we can do this. Okay. Okay, and here I'll change my my code. I lost my name here for P2 somehow. Okay, P2's name. Okay, remember we're dealing with a different object variable here. So, and here's P3. Okay, so we got 3 different instances of a person class in our program now, and each one has different state. This is the state, what actually is stored in there. So you can see P1's name is John, 36 is age, Ken, and 61, and Jane, and 22. So you can see the state going on here, the state for those objects, what's actually stored in each instance of our person. Okay, so back to our purpose of our class definition. Now, we haven't really written any methods yet, but we will. Okay, we will. So you can see here in this example, if we had a circle object, really the main thing you can say about a circle is it's got radius. If you know the radius of a circle, then you can calculate everything else. You can calculate the distance around the outside. You can calculate the area if you just know the radius of a circle. So these would be methods that we write to retrieve stuff. Now, in a perfect world, we would not want folks on the outside world to be able to touch name and age outside of our class here. Why? If we let folks that have our class monkey with stuff that's inside here, they can mess it up. They could set name to an empty string. Well, that wouldn't be right. You don't have somebody that doesn't have a name. They might set age to a negative number. Well, age wouldn't be valid then. So in a good object-oriented program, we would protect these things from folks on the outside world. Okay? And to do that, we would write some methods. We would write some methods to handle all the interaction so that folks can't do bad things to our name and our age. So starting to get into a little bit more about the last content here. So let's go on and look at the next one here, the relationship of a class to an object. And you can see here, if we had our class definition for a circle, it could have a property for the radius. We could say that we're going to write a method to get the area. We're going to write a method to get the perimeter. We're going to write a method to set the radius. Okay? This is our blueprint. Well, you just saw when we created the 3 instances of a person class just a moment ago. I created a P1, a P2, and a P3. Okay? Well, we created 3 different instances of a person. This is doing the same exact thing, except it's with a circle. It's with a circle. Okay? So, circle class definition, and then we have these 3 instances of a circle. Okay? And they have different names. This small circle could be a object variable in our program, regular circle, another object variable, big circle, another one. 3 different instances of one item, a circle. Okay? So, creating a class definition. Now, here's some sample code that I wrote for you that we can download and talk about. Okay? We've already talked about the constructor right here. The constructor, you remember I showed you how to write a constructor method? Okay? This thing gets run. This thing gets run when we bring a circle into existence. Okay? Now right now, it's got radius equals 1. What would that mean if that was a function that we had written and we had radius equals 1? That means that it's an optional, that parameter has got a default value. If we created a circle and we didn't pass the radius to it, then Python's automatically going to plug a 1 in there. So we made it an optional or a parameter with a default value. If somebody doesn't supply a radius parameter to us when they create a circle, we're going to automatically create one with a radius of 1. Okay? When you have this class definition, you remember I told you that the idea is to keep folks from outside of our object from ever messing with our private information? Well, this self.radius is some of our data, our state for a circle class. Okay? Ideally, we would want radius to be private, and we would write methods to let folks get to the radius. Okay? Now right here I told you if you know the radius of a circle, you can figure out the parameter of the circle. All it is 2 times the radius times pi. Okay? That's the perimeter, the distance around the outside of a circle. The area of a circle is pi times the radius squared. Pi r squared. Okay? So we wrote 2 methods here that let us get the perimeter. Okay? You notice we didn't store the perimeter. The idea is even in a database, if we had a database of circles, we would not create a column in our table of circles that had perimeter in it. We would not create a column in our database that had area. Why? Because we can calculate these things. We can calculate these things. Don't store something that you can calculate. Okay? So the only thing that we're storing is the radius. We can calculate the perimeter and the area. Okay? And here we gave ourselves a method to set the radius. So there's some nicknames for these things, okay? These methods down here. You notice I put a comment in there that says a getter method. Something that gets something from our class, okay? That gets something, they often call them getter methods. That return something, okay? If we're going to set something, they call that a setter method. Now you remember when we were first starting to talk about this Module 7 stuff, I told you there were 2 or 3 names for these things, okay? Another name for a getter method is a mutator. A mutator. When we say mutate, that means change, okay? That means change. Sorry, I'm telling you wrong. Okay, a getter method is another name for a getter method is an accessor method. An accessor method. Okay? So these are both accessor methods. Okay? Access something. Access is the same thing as get, right? So a accessor method or a getter method. means the same thing. Sorry. Down here where it says defines a setter method, where we're actually taking whatever they pass to our object when we're instantiating one and setting the radius to it, okay? This would be a mutator method. So another name for a setter method is a mutator method, okay? So that's a class definition. It's got a constructor here. It's got a getter or an accessor method for the perimeter. It's got a getter or an accessor method for the area. It's got a mutator or a setter method for the radius. So this is a complete class definition pattern for a circle. So I'm going to go ahead and save that into my little folder. Okay. The desktop right there. Circle.py. Let's save that. Okay. Let's go down to the next one. Here is instantiating an object from our circle.py. So let's go ahead and take this code right here, and I'll go into Tani, and let's kick the tires on our circle. Now, check this out. From circle, import star, just like what we did when we were working with the turtle objects back in Module 1 of our class. Okay? Except instead of from turtle import star, we have from circle import star. Where is that circle? Right here it is. You see it's in the folder. It's going to need to be in the folder with our program. So I'm going to go ahead and do a file and a save as, and I'm going to call this program circle test.py. Okay? So this is bringing all that code from our class definition for a circle. It's bringing it into our program, just the same as if it was all up above this code right here. Okay? Just the same. So, just making sure you understand here, when I open up circle, all this code right here is actually getting brought into our program by this line right here. Now remember, this circle.py has to be in the same folder as our program that's going to import it. Okay? So this is importing it. This is creating a small circle, and it's got a 1 right there. So what's going to happen? When it creates one of these things, the constructor's going to run. We're passing a 1 to it. So radius is going to get a 1 put in it. Okay? Radius is going to get a 1 put in it. So if we wanted to know what the area of a circle is that has a radius of 1, then we could call the getArea method on it. So let's just do that for a second. Okay, here I'm creating a circle. Okay, and here let's do the area of small circle is, okay, small circle dot get area. This is our accessor method. Our accessor method named getArea. Okay, right here it is. Okay, get area. Notice I'm not passing self to it because I'm outside of the object or the class. So let's run this and see what we get. The area of small circle is 3.1415, which is actually just coming from pi, right? It's coming from pi. The area is pi times the radius squared. Well, 1 squared is still 1. 1 times pi is 3.1415. So you can see that we just instantiated an object from our circle. You can see kind of what happens here. When we have that class definition in our program, Python puts it into memory. This is step 1. Okay. We have then when we instantiate an object from that blueprint, Python runs the class constructor. It creates that variable, that property for radius, okay, right here, okay. So that's what happened. That's what happened in this code right here when I imported my circle.py and then I instantiated an object. So we've been running for a while here. I'm going to go ahead and stop, and we'll break this video into at least 2 videos so that it's not quite so long. So just as a review, we have gone all the way through our Module 7 material. Everything that I have highlighted in orange there is what we have covered so far. So you can see these links are mostly one-pagers. So I'll see you in part 2 at least of Module 7's material here. Good luck with the object-oriented programming. It's a very, very powerful way to write programs, a very reliable way to write programs, and makes them a lot easier to understand. So, good luck.